All right, so here's more about inequalities. Day 2, actually no, lesson 2 of topic 1. Oh my goodness, I messed that up. So unit 1, topic 2, lesson 2, day 1. So this is a 2-day lesson. Solving inequalities here. So we got some pretty straightforward inequalities. I'm going to split them just like I would with an equation and solve them just the same as well. Add 9 to both sides. Addition property of equality, that leaves me with 2x is less than 12. Divide both sides by 2, and I've got an answer of x must be less than 6. Over here, same thing, split the inequality sign, add 3 to both sides, and that gives me 4x is greater than 16, and then divide both sides by 4, division property equality, that means x must be greater than 4. All right, so pretty quick and easy warm-up there today. This lesson gets into writing inequalities and think about inequalities in the sense of which one's greater than the other. So in this question, you had 3 choices. Either the first statement's bigger, the second statement's bigger, or they're exactly equal. Or actually, there is a fourth answer. It could be it can't be determined, and that's basically what the directions say right here. So if I told you y is less than x, and then I said x minus y or y minus x, which one's got to be greater? Well, if I told you y is the lesser number, y is less than x, and that means x has to be a greater number minus a smaller number is always going to be a positive answer. But a smaller number minus a bigger number is always going to give you a negative answer. So it can be determined which one is greater. So in this case, if this has to be a negative and this has to be a positive, then that is the greater answer. Now I can reveal the answer here as well, but it's pretty much everything I just stated, and this is my algebraic reason why of what I just said. So there's a lot of thinking going on in this lesson. This is a great lesson, and some of these questions can be very tricky. I'm not going to go over all of them, but I will do a couple more. So a is greater than 0. That basically tells you that a has to be positive, and then b has to be negative. So which would be greater? A positive times a negative? Well, that's always going to be equal to a negative answer. Or a positive divided by a negative? Well, that's also going to be a negative answer. So this one is actually, it kind of depends on what you make a or b. So you can actually make it. So it really can't be determined. It's not possible. So depending on what you give it, so here's the case. So if you make a 2 and b negative 2, you plug those two numbers in. So multiplication gives you negative 4, but division would give you negative 1, a greater number. So as you can clearly see, so it goes through case by case. Case 2, determines whether or not it could be greater or not. All right, so question number 3, 2x minus 3 is greater than 7. Which is greater, 5 or x? Well, if you just solve this, you find out that x is greater than 5. So, I mean, if you solve it, x is greater than 5, well, boom, then x must be greater than 5. There you go, straightforward. Okay, that one's pretty easy. Same thing goes for this. If you solve this one, keep in mind that it has a negative involved, and when you have a negative, you gotta flip the sign. When you divide both sides by negative 2, subtract 10 makes this negative 4, divide by negative 2 makes positive 2. You end up getting an answer of x is greater than 2. So x must be greater than 2 in the end. All right, so I am going to, you know what? These are pretty short enough. I'm going to go over them. In the next video, I might skip a few more, though. 4 times something equals 0. Well, that means x has to be 0. So therefore, 1 is greater because x has to be 0. It can't be anything else. If n is, so I do like this one also, which one is greater? If n is an integer. Now keep in mind, an integer can be both positive and negative, so it can be one or the other. So n here could be a positive, it could be a positive 10, it could be negative 10. We really don't know. And the opposite of n, well, if I told you n was negative 10, then this one would be bigger because the opposite of negative 10 would be positive 10. But if I told you n was positive 10, then this one would be negative 10 and this one would be positive 10. It'd be the exact opposite. So this one cannot be determined because it really depends on what kind of number it is. If I had told you that n is a whole number, that'd be a completely different answer, other than the fact that 0 could have been the same for both, assuming that n was greater than 0. So that means that it's positive. All right, so let's move on. All right, so, okay, those were tricky ones, and I'll explain those more in class. So tonight's homework, solving it just like you did the warm-up. This is a pretty straightforward homework. Nothing too tricky here. So that means x has to be less than -3. So then all you got to do is set it up so that you have -3 in the middle of your number line. Okay, so I probably went over this in class, but an open circle means not or equal to. Okay, and a closed circle means or equal to. So, all right, let me erase that. I don't like the way I wrote the notes. So if it's open circle, that's either greater than or less than. Can't be anything else. If it's a closed circle, it's going to be either greater than or equal to or less than or equal to. In other words, a closed circle represents it can be that answer. So you might want to ask yourself, well, can x be -3? No, it can't, because it just says it must be less than. So it's a open circle, and it's pointed to the left because every number that's less than -3 is to the left. -4, -5, -6, -7, -8, and so forth. All right, and this one, add 4 to both sides. That gives me x is greater than 17. So I'm going to throw 17 in the middle. Once again, it's an open circle because it cannot be 17. And everything that's greater is to the right. Now, keep in mind that make sure, and hopefully your teacher last year even expressed this when you first saw inequalities, that you always want to have the variable on the left-hand side. I understand that this is the exact same thing as this because all you have to do is flip it around. But if you flip the numbers and the letters around, you have to also flip the sign around. So if you end up with this as your answer, make sure you change it to this. So you don't really want this. Even though that's the right answer, you want it like this because x is greater than 17. Greater than, now you know all the greater numbers are to the right. So that's easier to graph. So when you're graphing, you definitely want to have your variable on the left-hand side. Not because you have to, just because it's easier to understand which direction it's going. All right, so that concludes another homework.